This is the stuff we did last Friday. Hopefully you all had a nice weekend. We talked about how we do long division in general, and how we end up with a quotient up here. That's the remainder, and then that number right there is the divisor. So when we did 6 into 25, it goes 4 times, but there's 1 left over. So that right there is the remainder. 4 is the quotient, and 6 is the divisor. So if we write down what the answer is the quotient plus the remainder over the divisor. Now with numbers, it's pretty easy. I mean, you're pretty familiar with how to do that. So we write that as a mixed number, 4 and 1/6. I wrote 4 plus 1/6, same idea. Okay. This actually is going to be usually how we write those. Okay. And we say it goes in evenly if the remainder is 0. And what that means is the divisor is a factor of what we're dividing it into. That's called the dividend. You don't have to worry about that vocabulary word, but you should know the others. Okay? So we did this problem right here. This is the only one that we did. I just said, hey, let's look at this, think about how this works. And so we did this division problem. So we put the x minus 1 on the outside. We put the 2x cubed minus x squared plus 2x minus 3 on the inside, and then we did the long division. So that should all be something that you're pretty familiar with. And then I came down here and I showed you how to do synthetic division. I think I asked this before. How many of you have seen synthetic division before? Raise your hand. Okay, about a third or a half of you. Okay, so synthetic division only works if the number, so first of all, we have to be dividing by a binomial. So it's got to be x plus or minus some number. It doesn't work if this is a 2x or a 5x or a 3x or a negative 10x or something like that. Okay, it's got to be just a plain old 1x. The coefficient has to be 1. If you can do synthetic division, it works pretty darn well. Okay, it's a pretty quick process. So let me run through this again. I'm going to do this one by doing long division, and then the rest of these I'm going to show you using synthetic division if we can do that. So again, just a reminder of how we do regular old long division. So on the outside of the box would be a 5y minus a 2. And then on the inside, what do you always have to check and make sure of when you're writing down this inside thing? Okay. They got to be in order, and what else? Okay. Okay, it's got to be in order and it's got to be complete. If we're missing a power, what do we do to save a place for that power? We put in a 0. Okay? So this is going to be 10y cubed. Make that a little bit bigger, or a lot bigger. Then plus 6y squared minus 9y, and then plus 10. Make sure you write it down correctly also. You don't want to make any silly mistakes like that. And then the nice thing is, all we have to do is look at these first numbers right here, those first terms there. So we're just looking at 5y and 10y cubed. What do you multiply 5y by to make it a 10y cubed? Okay, so we're going to multiply by 2y squared. You put it straight above the one that you're computing it with. So this is going to be a 10y cubed. This is going to be a minus 4y squared. If this had been a plain old y, everybody watch please. If this had been a plain old y, you would have put it underneath this one. Make sure you keep them lined up, keep them all nice and neat. Okay. Then we're going to go through and we're going to subtract. So I'm going to subtract this. Subtract that makes it a plus. These go away. These make a 10y squared minus 9y plus 10. I like bringing everything down. You don't have to do that, but I find I tend to get the answer correct if I do that. Then again, I'm looking at 5y and 10y squared. What do we multiply 5y by to make it a 10y squared? 2y. So we're going to put a 2y up here. I'll multiply here. That's going to make a 10y squared. That's going to make a minus 4y. Then I go through and I subtract. So I'm going to change the sign of this one, change the sign of that one. So these go away. That's what we wanted. We want to slowly get rid of all those powers. We work our way down from 3 all the way down to 1 or 0 or whatever. This is going to be a minus 5y and then a plus 10. And then I just look here. What do I multiply 5y to make it a negative 5y? Just a negative 1. So I'm going to write a negative 1 here. And then I multiply. So this is going to be minus 5y. That's going to be a plus. Okay, just watch this real quick. Whenever I do these, I like just writing down the signs. I'll only write down a negative. If it's positive, I'll just leave it alone. So this is going to be a positive 2. And the thing that does is when you go through here and you change the signs, that's going to be a plus. What's this going to be? That's going to be a minus. So that gives us 0 y's, and this is going to be an 8. Okay. What does this mean? Remainder's 8. Okay. So did it go in evenly? It didn't go in evenly. Okay. So this right here has a name. What's that called again? Okay, that's called the quotient. There's the remainder. And here is, what's that called again? Divisor. So the answer to this problem would be, we'd write down the quotient, so that's going to be 2y squared plus 2y minus 1, and then plus the remainder, which is 8, over the divisor, which is 5y minus 2. Okay, that's the way we'd write the answer. Okay, any questions there? Okay, that's long division. Could we do synthetic division on this one based on what I told you a few minutes ago? Nope. Can't do it. Because that's a 5y. Now, there is a way that you could make that into just a plain old y. You could divide that by 5, which means you'd need to divide the top by 5, which would produce fractions. It's usually not worth it. It's not that it's impossible, it's just not worth it. Synthetic division is designed to make it a little bit easier and quicker to get the answer. Okay? All right, can we move on from here? Okay, let's take a look at the next one then. So we already did this one right here. Let me just review the process. We put a little box right here, and in here we put a 1. Where that 1 came from was this right here. Whatever this number is in the divisor, we take the opposite of that. So if this is a minus 1, we put a positive 1. If this was a positive 2, what would we put in the box? We'd put a negative 2. Okay? Then we write down just the coefficients in order. We make sure it's complete, as somebody said earlier, and in descending order. And if it's not complete, if we're missing a power, we're going to put in a 0. Okay, any questions? And then it's just bring down that first one, multiply, and so forth. Okay? So let's go ahead and do this one using synthetic division. So I'm going to have to draw a box right here. What goes in the box? So we put a negative 3 here. And then do we have all the powers represented? Are we complete and in the right order? So we're going to write down a 2. And I mentioned this before. Please make sure that when you're writing these down, you kind of equally space them. Okay, keep them nice and equally spaced. Notice I leave as much room for the negatives as I do for the positive ones. And I didn't even write down the sign in front of them. Remember, we just assume that it's positive if there's nothing in front there. Okay, any questions? Okay. There was one other thing that we can do that might help us get the right answer. Does anybody remember what it is? It's just kind of an organizational thing. We draw a little dotted line right here. And that reminds us that when we get done right here, whatever this number is behind that dotted line, it's the remainder. Okay? So again, synthetic division is really nice if you remember how it works. One, you've got to set it up right. You've got to make sure that these are all in descending order and that we aren't missing any powers. And you've got to do the opposite of that. Once you get to there, hopefully it's pretty easy. You bring the first one down. You multiply the two of these. Put it right there. That's a negative 6. And then you add those. So that's going to be a negative 7. Then you multiply. That's going to be a 21. And then you add. That's going to be a 23. Then you multiply. Let's see, that's going to be a negative 69. And then you add them. That's going to be a negative 72. Now, the arithmetic of finding the numbers in this problem, that's pretty easy. But then you've still got to remember what this means. Remember, this started out, let me put a different color in here. This started out as x cubed and it got divided by an x. So the exponent on this one, the power right here, is reduced by 1. So this is going to be 2x to the second minus 7x, and then notice how it just goes in descending order, just like we had it organized above, plus 23. Okay, now there are two ways to write this. I prefer writing it this way, plus the remainder of negative 72 over the divisor. What's the divisor again? X plus 3. I like writing it that way. If you want to write a negative in front of that, that's totally okay. So if you wanted to write 2x squared minus 7x plus 23, and then minus 72 over x plus 3, that's fine. Okay, either way is okay. I just like this because it's nice and uniform and consistent. Okay, are there any questions? Sure? Okay, what's wrong with this one then? What makes this one slightly more difficult? Okay, it is in descending order, but we're missing some powers. Okay, now the nice thing about this is a pretty long polynomial. It doesn't look like it, but with synthetic division, this is going to be pretty easy because we're going to write in the box is going to be a negative 2. Then I write a 1, a 0. Make sure you save the place. Notice how we're spacing this out evenly. We're now down to x's, and now we're down to the constant of negative 5. Do a little dotted line there. That'll remind us that the remainder's coming after that. And again, make sure that you've set it up correctly. If you set it up correctly and you remember the simple process, the answers are easy to get. So bring down, multiply, add. Multiply, add. Multiply, add. Multiply, add. Now, it's a pretty simple process, so don't make any silly mistakes. I brought the correct number down. I multiplied correctly. I added correctly. Multiplying here, let's see, you get a 4. That gives you a 0. When you multiply, you get a 0. So did I make any silly mistakes on this one? No. Okay. So what's left here, these numbers represent the quotient. What degree would the quotient be? To the third. It's 1 degree less. Sometimes we call this the depressed polynomial, okay, because it got busted from degree 4 to degree 3. So this is going to be x to the third minus 2x squared, and then anything else? Yep. Okay, no x's, no constants. It's just going to be plus negative 5 over x plus 2, and that right there would be the answer. Okay? Any questions? Oops. Okay, can you do synthetic division on this one? No. No. Okay. If you wanted to go through and divide everything by 2, so this would be x plus 3/2, and this would be an x to the third, this would be a minus 1/2 x, this would be a plus 1x, and this would be a minus 3/2. If you wanted to go through and do it that way, that would be totally fine, but then you've got a fraction in every single part of this problem. Okay? Probably not the funnest thing to do. So on this one, what method would you be stuck with? You're going to do long division. So you're going to do 2x plus 3 on the outside of the box. We still make sure we have all the powers represented. Okay? So don't ever skip that step. And then just make sure you keep it nice, neat, and organized. Okay. Are there any questions? Sure? Okay. All right, let's finish this up, and then I'm going to give you a little bit of time to work on the assignment, and then I am going to get started on 5.2, okay? So it says, which problems above does the divisor go evenly into the dividend? Of A, B, C, or D? Oh, let's see. Should we go ahead and finish this one? Okay. You go ahead and work. I'll go slow, see if we get the right thing. I got negative 15 for a remainder. Does that sound right? Good? Okay. So here's our answer. X squared minus 2x plus 4 plus negative 15 over 2x plus 3. Okay. So now we can look at that other question. Of A, B, C, or D, did any of them go in evenly? Just A. That's the only one. Okay. Which of the problems above is, so A, which of the problems above is the divisor a factor of the dividend? Isn't that another way of saying which one goes in evenly? It is. Okay. So if it goes in evenly, what that means is that's a factor of the dividend. That goes in evenly. Okay. So if you were to take the quotient and multiply it by x minus 1, you'd get this polynomial right here. Okay? All right. Any questions? So if the remainder is 0, we really like that. And in fact, synthetic division is a really quick way to see if the remainder is 0. So the question here, this is a little bit different. This doesn't say do synthetic division. This says, is x minus 2 a factor of that guy right there? It's a big, long, ugly polynomial. How could we check and see if it's a factor? Divide. See if remainder is what? If the remainder is 0, that means it goes in evenly. Just like the problem that we started off with, 6 into 24. Because the remainder is 0, that means it goes in evenly. That means 6 is a factor of 24. So if all we have to do is check and see whether or not it's a factor, let's do synthetic division. So let's put a 2 in the box. Make sure these are all represented. So that's going to be a 1, a negative 4, an 8, a negative 16, and a positive 16. What are we hoping goes right here? We're hoping there's a 0 there. So let's see. Bring down, multiply, add, multiply, add, multiply, add, multiply, add. What's the remainder? Okay, now, are we interested in all this other stuff? Not on this problem. On this problem, it just said, is it a factor? The way you tell whether or not it's a factor is if the remainder is 0. Does it go in evenly? So the answer here is yes, based on that guy right there. Okay. Any questions? Okay. And can you do that one using synthetic division? Okay. Let's just take a quick look. Let's see how that one goes. So what would go in the box? Negative 1/3 in the box, and then I'd have a 3, a 1, anyone? 0. A 0, a negative 3, and a 1. Okay? So let's see. If I bring down and I multiply, well, this is good because I've got negative 1/3 times 1. What's 1/3 of 3? Or sorry, negative 1/3 times 3. What's 1/3 of 3? It's going to be negative 1. Okay? Add them, that's a 0. That's a 0. Add them up, that's a 0. This is a 0. That's going to be a negative 3. Well, pretty easy so far. Negative times a negative is a positive. And 1/3 times 3 is 1. So what's the remainder? Remainder is 2. Okay? So it is possible to do it with a fraction. Okay? It's just usually not as nice. Okay, any questions? Okay. All right. I'm going to give you about 10 minutes, okay, to work on 5.1. It's just these problems right here. There's only, what, 7 of them? Go ahead and try and get that done. They're pretty quick. Finish that up, and then we're going to take the last 15 minutes or so, and we're going to start 5.2.